two projects. In this video, we are going to see an advanced suicidal ideation detection using neural machine translation with machine learning technology. Introduction. Mental health issues like anxiety and depression are increasing in developed and emerging markets, leading to severe disorders and suicidal ideation. Suicidal ideation detection (SID) uses tabular data or textual content to identify suicidal thoughts. Advancements in social media and online anonymity have made online communication channels a surveillance tool for suicidal ideation, with mining social content potentially improving suicide prevention. Objective of the project. The project aims to create a machine learning system for detecting suicidal ideation using patient status information. The light GBM algorithm trained on a dataset uses neural machine translation to convert non-numeric features into numeric format. The algorithm is compared to the existing random forest method for accuracy, precision, recall, and F-score. The goal is to identify individuals at risk of suicidal tendencies and enable timely healthcare intervention. Requirements. These are the requirements needed to execute this project. Hardware requirements: operating system of Windows, processor of i5 and above, RAM of 4GB and above, hard disk of 20GB and above. Software requirements needed are Python, ideally of Python 3.7 version. To execute this project, we have designed the following modules. The first module is Approach Suicide Attempt and Stress Dataset. This module involves uploading the dataset containing information about suicide attempts and stress levels among individuals. This dataset serves as the foundation for training and evaluating the machine learning algorithms. The second module is Pre-processed Dataset. In this step, missing values in the dataset are identified and replaced with zeros to ensure consistent data format for analysis. This pre-processing prepares the data for subsequent algorithmic processing. The third module is Machine Translation and Features Extraction. The dataset may contain non-numeric characters that are not directly understandable by machine learning algorithms. The module employs Neural Machine Translation (NMT) using natural language processing (NLP) techniques to translate these non-numeric features into numeric format. Each unique non-numeric character is assigned a numeric ID, facilitating compatibility with machine learning models. The next module is Train Proposed Light GBM Algorithm. This module trains the algorithm to identify individuals with suicidal ideation. A variant of the gradient boosting machine, Light GBM, optimizes memory usage while maintaining high performance. It builds an ensemble of weak learners by iteratively fitting each new tree to the errors made by the previous ensemble. This method effectively addresses the classification problem of detecting suicidal ideation. The next module is Train Existing Random Forest Algorithm. The existing random forest algorithm, another machine learning approach, is trained on the same dataset. The random forest algorithm constructs multiple decision trees and combines their predictions to improve accuracy and prevent overfitting. In this project, it is used as the benchmark for comparing the performance of the proposed light GBM algorithm in identifying individuals with suicidal thoughts. The next module is Predict Suicidal Attempt from Test Data. The trained light GBM algorithm is applied to a separate test dataset to predict whether individuals in the test set exhibit suicidal thoughts. The model generates predictions based on the features of the test data. The last module is Comparison Graph. A graph is generated to visually compare the performance of the proposed light GBM algorithm and the existing random forest algorithm. Metrics like accuracy, precision, recall, and F-score are plotted, providing insights into the relative effectiveness of the two algorithms for identifying individuals with suicidal tendencies. Execution of the project. To execute this project, first we need to open the code folder. This is the dataset folder in which I have suicidal dataset folder and test data folder. I am opening the suicidal dataset folder. So this is the data. On this data we will train the models. Close this dataset, and this is the test data. So on this data we will predict the suicidal ideation. Close this dataset, and this is the Python main code file, and this is the run.bat file. Instead of executing the project in command line interface, we have created this Windows batch file. Double click on run.bat file. This graphical user interface will be opened. With this, we are interacting with the program. We have used Techn library to create this graphical user interface. Now click on Upload Suicide Attempt and Stress Dataset button. A dialog box opens. Select the suicidal dataset and click on Open. So in the text area, we can see a confirmation that the dataset is loaded, and here we are displaying the top 5 rows of the data, and there are 19 columns in the data. Now click on Preprocess Dataset button. So in this graph on x-axis I have no and yes. No means the person doesn't have the suicidal thoughts, and yes means the person have the suicidal thoughts. And on y-axis I have the count. Close this graph, and in the text area we can see all missing values are replaced with 0, and total processed records found in dataset are 469. Now click on Machine Translation and Features Extraction button. So here, after machine translation, all the non-numeric values are converted to numeric now, and the total dataset is split into train and test sets in the ratio of 80:20. Now train set includes 614 records and test set includes 154 records. Now click on Train Proposed Light GBM Algorithm button. So in the text area we can see the performance metrics of Light GBM algorithm. And now click on Train Existing Random Forest Algorithm button. So here we can see the performance metrics of Random Forest Algorithm button, and by seeing the performance metrics we can say that Light GBM is doing well. Now click on Predict Suicidal Attempt from Test Data button. A dialog box opens. Select the test data and click on Open. So in the text area we can see, in the square brackets I have the test records, and after the arrow we can see the predictions if the person has the suicidal thoughts or not. We can scroll down test area to see the results, the predictions for all the test records. Now click on Comparison Graph button. So in this graph on x-axis I have the algorithm names, and on y-axis I have the performance metrics, accuracy, f-score, precision and recall. And we can see Light GBM is doing well in all the performance metrics when compared to Random Forest algorithm in this particular project. Close this, and the conclusion here is, this project introduces a new method for detecting suicidal ideation using advanced machine learning techniques. Using neural machine translation and the Light GBM algorithm, it achieved high accuracy in identifying individuals with suicidal thoughts. The system outperforms the existing random forest method, offering timely intervention for at-risk individuals. This highlights the potential of technology-driven solutions in addressing mental health issues and improving patient care.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.